Hello, everyone. Hello, Queen. Hello there, Teufel. You were away for a while and left the square. It should reconnect you once you come back or something. I don't know. I think it should let you idle also for longer. Well, hello, everybody. And welcome to yet another stream. But today we are going to have fun, actually. Unlike every single other day, today is the day that we're going to have fun. Now, I might have said the same also for the last stream. No, I haven't. I didn't. But yeah, this is going to be cool. So the plan for today is so we're gonna do this. We are going to complete the schema checker that I was implementing. Yesterday I didn't want to really get into it too much because I needed time to figure out exactly how to cut the recursive stuff. And which, by the way, the fact that you cannot the fact that you have to write it recursively and you cannot add any loop to it, I think it's an interesting aspect of how Compline works in Zig. But anyway, that's a story for another day. So I did that work yesterday night. So I now have the proper function stubs, also more than just stubs, but there's still stuff that needs to be done. I realized also that I don't want types to embed their own schema. I actually want the schema to be a parameter to the build function. One schema that can contain multiple types, and then we name match the types in the schema, the top level types in the schema, with the top level declarations in the module that you pass. And that is the way. That is the right way of doing this. So we implement this, then we release Zine. Technically, we could also swap these two things around. Like we could, maybe it's actually better to first release Zine and then continue this work, because then the plan is to upgrade Zine to new Ziggy, which is gonna be fucking painful. I can already tell. And the reason why we do this is like the reason why the point is we make a Zine release before upgrading to new Ziggy, because we want to have a release that doesn't have all the Ziggy related breaking changes. And so that way we give people a chance essentially to see to try out, to experience bugs from the Zig update separately from the bugs from the Ziggy upgrade, because I suspect that both things that I've done recently are sources of bugs, and keeping them separate helps know which is which. So that's the idea. So let's go make the magic happen. Okay. So here the recursive code is now makes a lot more sense. I guess we can start from the top. So let's start from the build system, and let's have it accept a lazy path for the schema. So add type check step. Yes. Okay, let's see. Validates user provided types against Ziggy against a Ziggy schema. Types is a module whose root source file must only contain public declarations or containers that are meant. Okay, let's rephrase this. All public top level declarations present in the root source file of the provided types module will be tested, will be matched by name with corresponding type definitions in the provided Ziggy schema. The provided Ziggy schema what else do we say in here? Maybe we can say that if your Z type I would say it doesn't matter if your Zig type name does not match the corresponding Ziggy schema type name. What matters as you can use as the match you know what, let's rephrase this. If your Ziggy type name does not match the corresponding Ziggy schema type name, uh, make sure to. Well, here's what I essentially am trying to say. What I'm trying to say is that if you have that essentially you can do stuff like this. You can do const schema type name a equals import equals, I don't know, pub const my Zig type name. I don't think this is even necessary. I think this is enough. Yeah. If your Ziggy type name does not match the corresponding Ziggy type schema Ziggy schema type name, make sure to use a public re-export that does. This doesn't matter. This doesn't matter. This should go above. Oh man, it's ugly as fuck to end with this. See Ziggy options for more information on how to personalize this serialization for a Zig type. Okay. Now the schema is not going to be provided as source, it's going to be provided as a path. So like schema path. Where do we put this? Project, target, optimize types, and the schema path. To customize, yeah. Thank you. So schema path, project type, blah, blah, blah. Types, schema path. We create an executable. We add imports. And then we need to do, we do a run step, but then we need to do run dot add add file argument. Schema path. Path of the schema file. Yeah. So, okay, this all looks fine. Then we need to go to the type checker now. And now we do have an argument that we need to worry about. So after we have the arena, we grab the error. Oh, guess what? Now we need IO. So we have IO, we have arena, we make error. Now we parse the schema. So how do we do it? We could allocate our arguments, all arguments in a list. We could ignore extra arguments. To be fair, this is a process that we manage through the build system. It's not meant to be invoked from the CLI by the user, so we don't need to have like a, you know, good error checking for the CLI. So we can just YOLO grab the right CLI argument and call it a day, which I think that's what I will do. So actually, I haven't done the iterator approach in a while. Let's see how that works. Like that looks like. So const, actually var args it equals init dot minimal dot args dot there we go, iterate allocator for Windows GPA. It wants a GPA. Well, guess what? You get an arena. And that means that we don't even need to defer the init. We don't care. So we do underscore equals args it dot really? There is no, I think it's skip for the first one. And then we do const schema path equals args it dot next dot question mark. Actually, not the question mark, or else panic missing schema path arg. So it's not like I'm going to YOLO everything, but because that doesn't matter. But we don't care about making this nice. So schema path, we have it. Now we need to procure ourselves the schema source. So const schema source is going to be IO dir cwd read file unlock options. Yeah, there's a few options. Okay. IO, yes. Sub path, schema path. Path. Okay, I'll fix it in a moment. Arena. Limit. Ziggy dot max file size. Alignment. I think this can be at 1. Sentinel 0. Okay. This can obviously fail. And these failing, so not passing a CLI argument, something is wrong. You're not using the built-in function in the build system. That's a problem. Not finding the file, that is more likely because maybe you passed in a b.path, something like you typed the file path. So this is an error that we need to show correctly. So we need to say std debug print unable to find file, or rather unable to read file. And then we print the error message. And then we're going to call it a day. So schema path, and then the error. Oh, we need to call it E because we already have R. Okay, so that actually means that this guy can be defined below now that I think about it. Yeah, we need only from here. So with this, we have schema path and we have we have schema path, we have schema source, all well and good. Null delimiter at the end. I think this might need to be made different because limit is an IO limit, so we need to say limited. We need a constructor. Is it max size? You already use full init, you can just grab the GPA from it. Yeah, but then I need to free stuff from it if I need to free stuff from it if I use it, and I don't want to get complaints about leaks. So I'm just going to use the arena. This is a one-shot executable, so who cares? Okay, blah, 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 blah. Error, build the AST, complain if it's wrong, exit one if it's wrong. Otherwise, start looping, find all decal names. We can assert that this is a struct because it's a module. if the types that we see, if we see a type that is not a struct enum or union, we complain because we expect to find container types there. So that works. Then now that I think about it, if we find a decal that is not a type definition, we need type of, right? We also need to check type of. If type of T is different than type, that's also a problem. There is a CD process fatal. Um, yes, you're right. It's fine. I like this. When passing an arena to a complex process expecting a GPA, will the inside the inits just be optimized out? Kinda. An arena can only free the last thing that you allocated on it. So that means that if you have a create something or alloc something, and then you don't have any allocation in the meantime, and then you free that last allocation, yes, the arena will be able to make a free because it essentially will move back the water level. An arena doesn't track individual allocations. An arena only tracks up to what point it has consumed memory. So the very last allocation allows it to pull back that number when you free it. So they are not going to be entirely optimized out, the inits, but a init of something that is not the very last allocation, yes, that will be an op, essentially. Okay, so yeah, if it's not a type definition, we should complain. If it is a type definition, but it's not one of these bad boys, we should complain. If it doesn't have Ziggy options, we are complaining. But in reality, we don't have to. So I just realized that, yeah, this is really not strictly necessary. So we are taking these checks out. So that means that we cannot guarantee, like if the type has its Ziggy options, awesome, but it might not. So these guys are coming out. The reason why I'm changing this is because previously we assumed that the type would contain the schema definition. We had this field right here, schema, right? Which meant that you had to have this defined. But now we are taking this out. We're saying, no, it's not necessary. So you can validate even types that don't have a Ziggy options defined. So that is fine. Then we start validating this Zig container every time we find one. And validate Zig container. So here's what we know here. Let's put in asserts what we know. We know that T is a type, yes. We know that type of T is type. Okay, so we know that this is a type. That is essentially the only thing we know about it. We don't know much more than that. Actually, never mind. We don't even need to assert it. We have it in the signature. Okay, never mind. I was trying to be clever and write down the things that we know and we don't know, but it's fine. You could validate your schema against STD types with this, for example. unlikely, possible, but unlikely that you would want to do that. You could imagine some cases where a grow-only arena would be more performant in that case. Um, yeah, of course. But you know what? It wouldn't be particularly much more performant because um, freeing in an arena is not the same as freeing in a general purpose allocator. So all it does is you call free. It looks at the pointer of what you're trying to free, multiplies the size of the element times the number of elements, or times one if it's a single element pointer. Factors in alignment if necessary, and then subtracts that number. And then it says, okay, I have the arena is filled up to 1,000 bytes. Is this pointer 1,000 minus the size of that data? If the two numbers match, then it pulls back to that number. Otherwise, it doesn't do it. So long story short, it's not loading anything from memory. It's just doing a tiny little bit of math on a pointer. It takes not very long to compute that stuff. So I would say that the difference is close to nothing, and the fact that you save some memory, I would say, is much more likely to be a useful feature. But sure, if your point is to remove every single operation that is unnecessary, yes, you could free yourself from some unnecessary operations in that case. But in practice, I think that what this what the current implementation of Arena does is strictly preferable for all normal use cases. So sorry, the reason why I think that validating in the schema against STD types is more unlikely is because usually when you use an STD type, you kind of want to abstract it away. Like you're using a hash map, you don't want to serialize the hash map one to one. You want to turn the hash map into the more conceptual data type of a dictionary, right? So you want some transformation to happen there. I think that's usually the case with types in the standard library, although it's not a hard rule. I'm sure that somewhere in there might be a type that makes total sense to map one to one. Okay, so validate the container. Starts from the global scope because we expect these guys to be in the global scope. T name, I think we need to rename T name to decal name. And keep in mind, decal name is different than at type name on T. Hello, Shubham. And each has its own like utility. So we grab this type from the global scope types. I actually don't know what we get in return. I don't know what the type of this guy is. So we do get some kind of node back, the index back, I think, but there might be also more. So let's go figure that out. Where do we go find that out? We go to schema AST. What's in there? Never mind. Types just straight up map to their own index. So that means that we don't know what type that container is. I guess we know this from the node type. The node tag should tell us that, right? Yes, it will tell us struct or union. Hey, Zig here. Hello. Quite unused to dragging around and passing stuff like ini.gpa and ini.io from entry point and through the whole code base. I also believe pre-016 this stuff used to live in STD. In mature projects, do you keep dragging it around as separate arguments or do you come up with some fancy context? A bit of both. It depends on what you're doing. It's not a big deal to drag it around. The reality is that not all your functions need to do IO. And if you just need, you know, quick and dirty debug printing, you use std debug.print, which doesn't require you to have an IO instance around. So it's not the end of the world. It's like dragging around an allocator. Sure, you pass those around a bunch, but not all your functions need to allocate memory. And I don't know, such is life. As for do you come up with context, that is an option. Yeah, sure. I don't know what whether that's right or not for your context really depends on the specifics of your context. There is no absolute answer. To give you one example, the reader and writer interfaces, they bundle the IO instance inside of themselves. So if you're writing a function that consumes a reader, reads from a reader, or writes to a writer, that function will not have to accept an IO argument because because the reader/writer interface will bundle it already. Because whenever you're using one of these guys, you use IO anyway. So I don't know. Okay. So the node tag will tell us what type of container we are in. Cool, because we're gonna need that in a moment. So okay, so that does actually give us the node index. So let's get also the type node. So we have the type node. Actually, I don't think we even need the type node. We can just immediately get the tag. And somewhere, I mean, I might even have a union that says struct or not, something like this. That doesn't matter. So type no type kind. Okay, so we have the type kind. We look at type info. We have the case. I think we might want we might want to do this twice or something. Let me think about it for a second. No, it doesn't matter. We can switch case in here, I guess. So if it's a struct, if type kind is different than what's this tag? Struct as well. Then we need to complain. Error.report key. It's not a problem of field. It's a problem with regards to the full type. And what we want to say is that this type we say expected is kinds t. No, do the opposite. Schema expects struct. No, okay, the other way around. Is blah 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 while schema expects blah, blah, blah. So type is case, while schema expects type kind. I think type kind, we should say, oh, well, it's already not scoped with, not understood. It's fine. Okay. So we do this, and if there's a mismatch, we just return at this point because we don't go any bit deeper. It's a mismatch. Then for union and enum, so both Zig unions and Zig enums should match Ziggy unions, because Ziggy unions, like a Ziggy enum is essentially a Ziggy union where all the payloads are void. So at this point, we are good. So switch type kind, and if it's well, union. Oh, actually, wait, we only have union. Okay, so it's another if. Okay, it's the same thing. So if it's a struct, and the type kind is not struct, we can even avoid parameterizing this. Here we can say is struct. While schema expects something else. Oh, this is misleading. Or it's not, I mean. Are you aware of what went into the decision to move IO stuff from ICD to init.io? Was it making more obvious and easier to test the main driver, or the main driver was something different? With init.io. Okay, I think you mean previously you were doing std.fs, std.this, std.that to do IO, and now you go through the IO interface. So it's not exactly init.io. Init.io is how you get an instance of the IO interface, and then everything is IO dot their IO dot stuff. Yeah, the decision making is this. I wrote a blog post about it. I wrote a blog post here. Zig's new async IO. We see half of the screen. Yes, you're looking at a short, I think. Actually, it says not connected. What the fuck? So if you're looking at a short, there's nothing I can do about it because stupid fucking YouTube doesn't want to implement the thing where I can decide where what to show on a short. So you'll have to open the full stream. There's also a full stream on YouTube on my channel if you if you want to see what's going on. I'm sorry. I don't know what to tell you. So this is it, yeah. Okay. So if type kind is even union, E is of kind, blah blah blah. What schema expects? You know what? Let's do it like this. A struct A union. I mean, also why T? We know what we know what type kind is gonna be. It's gonna be union. There's two type kinds here, union and enum. So yeah, the argument is not even necessary. Well, schema expects a union or enum. Actually, we know which one it expects, or rather, we don't know yet this information, but we know that it's going to be only one of these two, not either. Fuck. Fuck. I think we need to. I think first we need to do this. Const union is enum. Ah, okay, I'm not going to go insane over this error message for now. It's fine. We're going to make it better afterwards. Okay. This is good. Fine. So we checked that okay, test container type match. We have done this. Then the next thing that we do is look at all fields. If we check that that the name of the field matches. If case is different than enum, what is case? That would be our type. If our type is different than enum, then we check types. I feel like there's something missing here. So if our type is an enum, we don't check type? No, that is not correct. If our type is an enum, we need to check that there is no type expr. So what does that function do? No type expr? Wait, what? Am I hallucinating this? Am I in the schema ASC? I am. Where's type expr? Type expr asserts that the node is a type expr node. Oh, but this points at the field. This doesn't point at the field type. Hey, Christoph, what would you say the biggest reason to learn Zig and the biggest reason not to learn Zig? Lastly, which industry will strive and which will fail? Oh, I see some lightweight questions for me, huh? What would you say the biggest reason is to learn Zig? if you are a professional software engineer and you are spending the majority of your life writing software and you want to have a career progression where you essentially become a master of computers in the sense that you can have the hardware, you can push the hardware to the edge of what it can do, and you can create for users innovative experiences that were not possible before, that did not exist yesterday until you have made them, then you want to learn a lower level programming language. As long as you keep using Python or JavaScript, you will be limited in what you can do. If you want, for example, to create software that an end user can install and run on their computer trivially, how do you do that? How do you do that with Python? Python requires an interpreter. I guess you can do janky shit to kind of make it work, but your solution will be, it's guaranteed to be strictly inferior to somebody else doing the same thing that you have done, except in a lower level programming language, and their version is going to be significantly faster, less memory hungry, less janky to install, better integrated with the system. So if you have an interest in that, not just, you know, essentially being the breadwinner, well, not in it's not just a matter of having being able to be employable. It's a little bit past that. You care about this stuff and you want to do it well, and you want to not spend your life jailed inside of some kind of restricted play area sandbox that you cannot exit. Then you need to learn a lower level programming language. Whether that should be Zig or another lower level programming language, that depends on a variety of factors. In my opinion, the main of which is your own sensibilities, what clicks for you and what doesn't. So, for example, there are people out there who really click well with Rust. They should use Rust. They have nothing to gain from Zig, or rather, there are maybe some things that they would gain from Zig, but if their brain works in the way, like it maps really well to how stuff works with Rust, Zig is going to be pain. But vice versa, there are people who really do not mesh well with that way of doing things. I don't like Rust. I don't like C++. I don't like heavily abstracted code. I find it detrimental to my understanding. I do think it's a little bit more than that, but in any case, that's just my opinion. So it doesn't matter. The point is, any of these choices is legitimate. Yeah, so that is it. That is literally it. As for which industry will strive or which will fail, you might want to rephrase this question in a slightly more precise manner. What are the two? Wait, what industries are you asking me to compare? If you are building desktop app in Python, you're essentially loading a gun to shoot yourself in the foot. Yep. I love Python, but I know that when stuff gets serious, you do not touch Python. I've gotten a ton of utility out of Python in my personal life. When I was in university and I was getting started, all course stuff in my programming course was in Java, and I never gave a shit. I did all my coursework with Python, and I would, do all the exploration with Python and then write the Java version at the end. And one of my Python lines was worth 5 of somebody else's Java lines. And it was awesome. So I got a very good time with Python at the time. I also made a few websites using Django, some professional ones. I got paid to do Django work. Django was a cool framework. In some ways still is today, maybe. And so, yeah, but then I moved away from Python and I moved to other stuff. Now I'm doing lower level programming. And the reality is that there is this idea that, lower level programming it's a different class of programming than higher level programming. And it's significantly harder to get right. I don't feel that way anymore. Actually, I feel the opposite. I feel like that if I had to write software like the one that I'm writing now, in Python, not only and again, I'm saying Python not just to hate on Python specifically. I'm saying Python to say a higher level programming language. So the same would totally apply to Java and whatnot, JavaScript, Java, JavaScript, and whatnot. And I think I would have a significantly harder time getting this right. A language with dynamic typing would make it harder for me to do refactoring. And I would not be able to use the standard library and company because they do inefficient bad shit. Like there's a lot of ill-designed things in higher level programming languages. Also dependencies. There's an overuse of dependencies, but at the same time, dependencies in higher level programming languages oftentimes kind of suck. And this is not to say that each and every package that exists in the Zig ecosystem is guaranteed to be high quality. Absolutely not. But there is a lot more thinking that happens, at least for now, around here. And when you find a good dependency in Zig, that will usually have thought out more precisely how to do things than your average JavaScript library, for example. There is no left pad in Zig, thank God. Or maybe if there is, everybody knows that you should not be using it, and you will not find serious Zig libraries that will depend on that Zig implementation of left pad. Would it work good in corporate world versus game engineering? Which industry is the best for Zig in your opinion? Which industry would it suffer the most? Okay. Opening the question based on your interpretation. Okay. So what is the stuff that Zig does best? I think is what I just described. If you have a need to write software that is precise in the way that it uses hardware, the reason why you're doing this is because your goal is to create a new experience that wasn't possible before. Zig is a great choice. And this sounds very high level, but it is actually very concrete. Like, I invite you to think about my words not as, general marketing mambo jumbo. I'm being precise. So if you're writing, if you are writing a, let me think about it for a second. If you're writing a silly to-do app that all it does is basic, very simple to do. You write text, you save text in a list of saved text snippets, and you don't want to move past any of that. That experience is not innovative. You're not trying. You're not trying to make good use of the hardware, and you're not trying to innovate. You're essentially creating yet another version of something that already exists. You can do it with Zig, and you maybe can have a good time. Maybe for you personally as a developer, doing it in Zig can be better than another language, or could be also be worse. But in any case, the best that you can get from Zig is a better developer experience at that point. But if you're instead trying to do something complicated, you mentioned games. Games are an example of that, but it's not strictly games. I'll give you another example. There's these guys. Tiger Beetle is a financial database. It's written in Zig. And as far as I know, this is probably one of the most solid databases out there. If you're into databases, you will know probably what the Jepsen test is. They went through Jepsen, and Jepsen found pretty much nothing. While you have other major databases that go through Jepsen, and essentially every single one of their claims about consistency guarantees is actually wrong because they have bugs all over the place. This one went through it, rock solid. Another thing that Tiger Beetle does, which is interesting, is that it allocates memory up front on startup, and then it never allocates memory afterwards anymore. Only at the beginning. Afterwards, it doesn't do it anymore. So this becomes an interesting thing where Tiger Beetle, the executable, cannot crash with out of memory while running once it's done starting up. So there's that. They also, for consistency, they use lower level APIs in the system to make sure that they use the right timers, they use the right primitives for accessing the file system. So they do all this stuff. Did space-time go through Jepsen? I don't know. I don't think it did, but I might be wrong. So, pretty cool database, and it's written in Zig. Somebody should vibe translate Tiger Beetle to Rust. Yeah. So, yeah, this is an example of trying to do something that is not really, that has never been seen before. You know, well, databases have existed before Tiger Beetle, that's for sure. But this specific combination of things is unique to Tiger Beetle. It's pretty innovative. They went really deep into making sure that everything works as expected. They're using Zig and they're having a good time. So this would be an example of where Zig would be a good fit. Another example of something that would be a good fit for Zig, I personally think of this as like the quintessential example of where Zig would shine, is, for example, firmware for digital cameras. A digital camera is a piece of hardware that has everything under budget. Memory is under budget. Battery, so energy, is under budget. Heat is under budget. And it has to operate in real time. It has to record and compress and apply filters and do whatever the fuck it needs to do in real time as you're recording video. So that is an example where you need software to be as efficient as possible, because that is what makes for a better experience that either is possible today and wasn't possible yesterday, or something like that. So for example, before software got good, well, hardware also had to get good, but software also had to get good for you to get 1080p, then 2K, then 4K video, then high frame rate video recording, then low light, all these things. Also, what's it called? Fuck, I forget the name, but the thing where you shake the camera but you don't see the video shaky, that also has a serious software component. So better battery life and whatnot. So all these things require software to be precise. Zig is a great fit for that. Yeah, video stabilization. Thank you. You said that also in audio recording devices. For example, the birth of Float 32 recording, that also is pretty good shit. So this is the general idea. And Zig shines in when it comes to this kind of stuff. If you're trying to do web dev, you work at Facebook and you're trying to make yet another web dev thing that, like an ad backend for Facebook. I don't know, man. Use whatever you want. It doesn't matter to me. Doesn't matter. So yeah, enterprise software development probably doesn't care too much about Zig. Because when I mean enterprise, I mean places where they use C#, for example, because usually in those contexts you cannot afford to be precise with what your hardware is doing. Like you have different issues. It's an entirely upside down world, so they should keep using C# and whatnot. Hey Dylan, thank you for the raid. Holy shit, 83 people. Hello everybody. Welcome. So welcome raiders. We are taking a short break while chatting about why learn Zig or not learn Zig. So if anybody has questions about this stuff, I'm happy to answer. Also, this is a no LLM stream, which doesn't mean that, I hate LLMs, and if you mention them, I'm going to get angry. But I personally do not use LLMs as I'm writing. So you will see me type out the code like a caveman. So you decide whether you enjoy that or not. And what else? Yeah. So and in the meantime, I am working actually on my data serialization language. So I'm working on this. I'm taking a short break as I chat with chat, but then we're gonna keep working on this bad boy. And I'm about to make a new release of my static site generator. So, do you think if we pushed it enough, Linus would allow Zig in the kernel too? No. Double no. One no. First no is no, because Zig is unstable, and the kernel just cannot afford to have an unstable language in it. I think that would be an insane idea. Second no is I think I would encourage you to not think about this stuff in terms of, oh, should we push for Zig adoption from the outside. That is not how this stuff should work. First of all, well, from a optics perspective, it's annoying to see people from the outside tell you, hey, you should use my thing. You should use my language. That is annoying. People do not like that. Rightfully do not like that. So this is not something that we should engage in. But the second is, if you attempted to do something like this, you would be faced with a lot of friction and a lot of people like resisting that change, because it's not a change that you can really push from the outside. It's a change that has to come from the inside. Like kernel developers need, like a critical amount of kernel developers need to all say, you know what, I actually think that Zig would be an improvement over what we're using, and we should, and since we are going to be the ones who will benefit from introducing Zig to the kernel, we should go through all the pain, through all the friction, to all the pushback, do all the politicking necessary to achieve that outcome so that we can be the ones that benefit from this. If you don't have that perspective, you are guaranteed to burn out in the process. If you're not somebody who stands to gain from having to go through the process of introducing the new technology, you are guaranteed to burn out as you try to do that. But also, don't push Zig on people that don't want it. There's no point. I am new here. C program lover. Name means something. Can you explain what's going on? And you made Zig. I did not make Zig. I am part of the core team. I work at the Zig Software Foundation. My title is VP of Community. And can I explain what's going on? Well, I'm yapping at chat, but if you go to ziggylang.io, here you can see the domain. You can take a look at the data serialization language that I'm working on. It's a JSON alternative. Hello, Calder. About Zig when doing hardware firmware stuff, is there a way to know explicitly like what struct namespace is dependent on the underlying OS and which isn't? You know, like Rust has STD and core. Yes. In the case of Zig, we don't have STD and core because our standard library is meant to be mostly OS independent. So for example, in the Zig standard library, there is a hash map implementation, and that hash map implementation does not depend on the existence of malloc on the target platform, because allocators are explicit, for example. So for us, this distinction, like the no STD stuff, doesn't exist in Zig because you don't need it. Now, there are parts of the standard library that depend on OS features. So for example, if you try to access std.thread, then you're depending on a piece of code that needs to know how to interface with the operating system to do threads. But if you're not using it, then you're good. So in general, the standard library doesn't need an OS until you're looking at something that very explicitly is depending on OS stuff. Yeah, Soapstone makes a good point here. Bye-bye. I get a lot of this decision paralysis choosing between learning C3, Rust, or Zig. Oh, I don't have any quick way for choosing between one or the other. I would say that, so I'm gonna leave aside C3. I don't have an opinion on that, so I don't care. Let's talk about Rust and Zig. Rust and Zig are very different. If you like heavily abstracted code, if you like having, you know, destructors, if you like having high-level interfaces, you know, traits, and all this system that allows you to create powerful abstractions, then you will like Rust and you will like Zig less. If you find this stuff annoying, you will like Zig more and Rust less. I would encourage you either way, though, to essentially give a chance to both, in the sense that if you spent your entire life working with languages that make you want to write abstractions, and you never had the experience of using a language that completely strips that away, or, well, not completely, you can make abstractions with Zig. Comp time is good for that, but you are less, the language does not guide you towards doing that. nor will your dependencies expect you to do that. In that case, sorry, and so that means that Zig is qualitatively different in that aspect than Rust. So if you always did the heavily abstracted stuff, like if you in your life only did, I don't know, Java, C Sharp, I don't know, Haskell maybe. Well, although I have no experience with Haskell. I take that back. Let's say C Sharp, Java, maybe Rust, and you never made done without distractors, for example. You should at some point in your life take a moment, quote unquote, empty your cup of tea, in the sense that you should be in a mental state where you decide to try something radically different and then give Zig a try. There are people who discover that actually they never really liked the heavily abstracted stuff at all, and they were just being told all their life that the heavily abstracted stuff is the right way of doing it, right? You go to university and they tell you that you should do OP, inheritance, interfaces, runtime polymorphism, parametric polymorphism and whatnot. And so they kind of are used to think that that is the one right way of doing software, but it's not. It's just a way of doing software with its own pretty long list of caveats and trade-offs. So some people that are used to that see Zig as something insane, and I can totally see that Zig might not be a good fit for a good chunk of them. But I also think that if you see it as something absurd, you have the wrong perspective, because Zig is not absurd at all. It works really well for a lot of people, including me. That being said, if you're looking for a first language to learn, yeah, I don't know, man. It's complicated. I will say this: if you decide to start on learning Zig, here's my top three recommendations. One, go to ziglearning.org, click on the learn section, take a look at the learning materials in here. Number two, join a community, join an online community. And also, if you have a Zig day, so you can go to zig.day. If you have a Zig day near you, go and attend a Zig day. I have one in Milan, for example. That's I live in northern Italy, so this is the Zig day near me. I don't run it myself, but this is kind of what it looks like. We meet on a Saturday, bring laptops, and we spend the whole day working on learning / passion projects for the whole day. This is the kind of like social context that really helps you learn the language and get motivated to work on learning things. And my last piece of advice is, don't do anything web related. Like, chances are that you probably are somebody who has experience doing web services, because most of us do that professionally. I've done that professionally in the past. If that is something that you have deep knowledge of, don't go to Zig and say, oh, now it's a new language, let's make a website, let's make a web service using Zig. Don't do that. First of all, because Zig is kind of early stage, so we don't have, you can do that, but it's not gonna, you don't have yet a ton of super high quality, very well polished libraries to depend on for this. They're coming, they're just not quite there yet. We have been hacking on the new IO interface until very recently. Actually, we are still finishing that job. So, and then on top of that, you will have this problem where you will know web development really well, but you will be very new to Zig. So you will have this big impedance mismatch where you feel like you should be able to do this stuff because you've done it a bajillion times, and you know that at the end of, you know how it works at a high level, right? It's trivial at the end of the day, but yet there will be all these tiny paper cuts of things that you don't know how to do in Zig, and so you will feel non-productive because this is something that you should know really well, but then you're not going to be able to. So my recommendation is find a domain where your knowledge of the domain roughly matches your knowledge of Zig, so you can progress both at the same time, and you will not feel like you're being chained down by your lack of knowledge of the language, or even worse thing, that it's the language itself chaining you down. So, for example, if you've never done ray tracing, go and do ray tracing in one weekend, but in Zig. This book gives you C++ code, but you can translate that to Zig very easily. There are other examples. For example, Zig Ray Zig ray tracing, you will find a bajillion people that have done this. I've done this also myself. So there's on my GitHub account, there's this repository where I did the work myself. I also chose a different image on purpose, so because I'm special. But I did this work and I live streamed it, so you can find the recordings even in case you want to see what the process was. But you can find plenty of examples of that. So try to do something new, and that also will help you pick something that is not too ambitious, because thinking, oh, I'm gonna make a web server, it's gonna have let's encrypt and cross site tokens and whatnot. And it turns out that actually to pull the JWTs all over the place, and it turns out that to pull off that stuff, there's a lot of lines of code in between. So choose something that less well. That's my recommendation. Okay. Let me catch up with the present. Okay, there we go. I'm up to the present. Okay. Spammer in the Discord. Oh shit. Thank you. Thank you. Banned. Okay. So happy to answer more questions about Zig in case anybody has any. So where were we? So we were saying we are looking at fields in our container. If our type is an enum, then we know that the case is not struct. We know that the container, the schema container, is not a struct because we evaluate this above here. Let's put that into an assert. So we are gonna say that case, not case. We know that type kind is not struct. So assert type kind is different than struct. Validated above. So the question is, so type kind is going to be enum. Sorry, it's going to be union for Ziggy. The question is, does that have a type? Because if that has a type, that is a problem. Sorry, it has a type. If that has a type, then is a problem because it means that there is a union with payloads. And if our decoding type is an enum, our enum cannot have payloads. We would need to be a tagged union, but we're not a tagged union because case is enum. Case would be union if we were a tagged union. Which, by the way, brings me also to the fact that if we are union, union must be tagged. So I forgot that we also needed to do this. Huh. That is annoying. Well, we can do this. If case union actually we can do it like this. If type case union x dot so if it's a union, where is it? Tag type. Okay. and X tag type is null, then we need to complain. What is running in the top right terminal? It's just a text editor. It's flow. Flow control.dev. It's my text editor in general. This one is just a text editor with a markdown file open. Oh, I already had X. Oh man. I don't know. CX. I don't have a good name for this thing. Well, we can call it union info. It's not exactly right, but it is right with this. Okay. I guess X could be called container info, but do we ever use it anywhere? Yeah, for okay, container info. Do I have oh no, you're right. It's Helix. I opened it with Helix. Thank you. Yeah, this is Helix. I maybe you know what? Maybe I should just to, just to get no, I want to just to get rid of the muscle memory. I have F aliased to flow. But yeah, good point. You caught me. You caught me in my dirty lie. Okay, so we are checking that the union is tagged. That is awesome. Then we're saying if we are an enum, let me think about it for a second. Essentially, we kind of want to do this anyway. No, not all of this. Just this. X per source and then type X per. Why are we doing X per source, actually? I don't even think we need X per source. Yeah, we don't need that anymore. That can go away. So that means that we want to move these two above. And this is kind of an if-else situation. If we are an enum, then we want this to be null. So let's do it this way, maybe. Yeah. If this is now, I need to change how this function works. This function right now is not returning an optional, but we need to do that. What's the weird bar at the top of the screen? It's the macOS bar. So if types expression is different than null, then we need to complain, and we need to say, well, this you provided an enum, but this field has a payload. Technically, this is I don't know how. So the question is, do we present this as on a per field basis? Do we complain for every field that has a payload, and then we say, well, this field has a payload, but you provided a enum for deserialization, and that doesn't work. I think it's fine if we provide this per field. Also here we need to, when we error out, we need to pass the field. Actually, do we? Mhm. Yeah, this is kind of a janky place to put this. I think we could do better. I think we could do better. Yeah. Okay, we're wrapping it up here in a block of some kind. I don't know, and we're gonna place this up in here. So how do we test this up from above? It would be nice if Tian handled unnamed tags. How would those be displayed? Like, actually, what does happen? I think I've never tried to use T with an enum that doesn't have, well, to display an enum, an underscore in an enum value, essentially a nameless enum value. Okay, so pairless union. First of all, the container has to be a union. So actually, this can be an if. If type kind equals union, then we do stuff, else false. Actually, let's do it like this. If it's different than union, false, else, and then there's a payload. Then in here, we need to iterate all fields. So we do that with the type scope for type scope fields values. I don't remember what the values are for that type. Fields. Oh, nice. It gives me a lock and an index. Ah, that is so good, man. Who's this genius who did this? I am. But the question is the index to the field itself or is the index to the child node? That part I don't know about. But we can find out. Fields get or put container fields. we're putting in items len, and then we're adding a child. Okay, so we point at the field, not at the child of the field, which is a choice. So in the type checker, okay, so we need to change that function there to something better, I think. But essentially, we need to do this. Uh, what do we call it? Field. Let's call it field. We'll do const field node equals. Do I need to grab the whole field? It doesn't matter whether I grab the whole field. I actually care only about the index plus one. If it exists, um, if let's call it payload node. Payload node is going to be field.idx plus equals one, plus one. If payload node is lower than, payload idx is lower than stnodes.len. Oh yeah, but no, we need that node. No, well, we need this node. Okay. Uh, if AST nodes at payload index dot, I think nodes have a parent index, don't they? Yeah. Parent IDX is different, actually is equal to field.idx. Break VLK with false. Otherwise, we keep looking. But before breaking with false, we complain. Oh, wait a second. Why am I even creating this payload less union thing? Hmm. Yeah, because actually what we do is we complain here. Yeah, there is no break, there is no thing. More like this. Yeah, it's just a preliminary check. So if type kind is union and enum, do this check, which is something that we essentially would like to do here. Ah, yeah, we can move it. It's a better place to move it down here. Let's see. If case is union, if type kind. Oh my god, so many things that have the same enum values. Case, let's call this Zig case. If the Zig case is union and it is null, then we complain. If the schema kind, okay, Zig kind, schema kind. So if the schema kind is different than union, so essentially is struct. Okay, I'm simplifying things. Also because these guys have only two things. Okay. I think we can split this if in two. Oh shit. The code that I copied is gone. I need to recopy it. Okay, let's try again. So if the kind is union, oh, this is kind of an else. Well, let's do it like this. If the kind enum and the type kind union, do we not know that for a fact yet? Oh, it was this. Okay, so I think we can make it better. Yeah, this is kind of a mind fuck. I'm sorry. I have no idea how people would be able to follow what I'm doing. It's uh so many layers mixing together. Sorry, people. Such is life, though. Such is the gangster life. So if our Z kind is a union and an enum, and then the schema says, well, but I wanted a struct, then we complain. If instead it is a union that the schema contains, but we are an enum, so this is of kind enum. but the schema union has at least one payload. Okay, I think we have this part is done. Good. These can go back to being if they can enum continue. This can be put above. Is there an issue for that in the Zig repo? For what? For what? Okay, so now we're doing correctly. We got correctly, I hope, to the field checking. We're checking field names. Those match. If the Zig kind is not an enum, then we also check that the type matches. This guy is not good, as it is. Oh, sorry, this. I don't think this is a random consequence of how the code is written. I think that is a deliberate choice. I would imagine that the way this is structured is that it's asserting that T is a named case, and so it's not crashing with a panic. My point is that it's crashing with an assertion. That would be my guess. I have not seen the code. I might be totally wrong, but my point is that I suspect this is a deliberate design choice, which you can put into question, but as a design choice, not as a bug. I think. Obviously, I might be wrong. Okay, so validate field expression. Otherwise, report and essentially continue. This might be less cringe if I didn't start with this double checking here. Huh. If I kept them separate, I could do all the struct stuff in the struct case. Then there's a lot of overlap though. I guess this would have to be its own function. I'm not gonna touch this for now. I think it's gonna be fine. Okay, let's fix the. This is the last function that we need to fix. Once this down here is fixed, well, we need to get to passing tests. We can complicate our tests a little bit, and then we should be done. Okay, give me a sec. I'll be right back. Okay, I'm back. So validate field expression, huh? Okay, so we are inside a field, and that might be saying this field is of type foo or bar, a container. Or you might say, well, this field is actually, let's start with the simplest example. Like this field is bytes. Or maybe you should start from the bottom. No, let's start from bytes. So this says, the token says, you're looking at bytes. What do you do at that point if you're looking at bytes? Well, if I'm looking at bytes, I'm going to switch on the Zig type. And I'm going to say, if the Zig type is one of these guys, then great. Otherwise, we fall through. And fall through is the error that says, this guy has type which is incompatible with This error message might need tweaking, but as broad strokes go, that's fine. What do we do if instead it's a optional bytes? So previously this was a loopy switch, but I don't think this can be made a loopy switch anymore. So, for example, if this has optional bytes, then we expect, so here info says optional, so we need info. Info is going to be type info of F, the field type. And we're saying, well, if the field is optional, okay, in this case, I could actually just add question marks in front of these guys and be done with it. You know what? I think that's what I'm gonna do for now. I'm essentially replicating this. What about bool? Well, you wouldn't believe what I'm gonna do with bool. What about with float? Do we also have F16? We also have F16. We need to add F16 support. If type info f type is int return. I think we can also hack the optional info case. Actually, this is essentially what we're doing. Info optional const child info. This. It is. You know what? At least it gets highlighted by the grammar. I believe so. I believe this was not present in the past, and then it was added, I think, at some point. I don't remember all the details. But we'll see if the grammar is lying to me. No F80. Is that an airplane model? Is there an actual F80 that some people are using? Holy shit, that seems bad. Okay, so integer is handled, float is handled. So all the terminal tokens are handled, except one. We'll get to that in a second. Here we have the container tokens, though. Um, let's think about the slice sigil. So here's the problem. These containers can contain other containers. So this guy have to be recursive. This guy have to recurse. There is no way around it. So let's start with the dictionary sigil. So dict sigil. If F type is a Z dictionary. Oh no. Let's redo this guy from scratch. Okay, we see a dict sigil. What do we want to do? The only things that can correctly serialize, deserialize a dictionary are, well, technically a struct could serialize to a dict if it wanted to, but let's not allow this. So if f Ziggy dot get options from f, if options dot roll, well, we switch it, rolls any return sum that's how it is. We look at the we see if it is something that has options. If it is something that has options, then it needs to be either something that decodes anything or something that decodes a dictionary. Maybe this should be unreachable because we should handle any above unconditionally. Like if f is any, then there's no point in checking anything that's happening in here. Yeah, so let's do that. Bye bye, Shubham. So yes, this is the only thing that works. And then optional is the same thing. Wait, actually no. We do not. Wait. If this is a dict, we do not return. We look at the child and then we recurse on the child because then we need also to check that the child matches. So we call validate field expression. Let's see if now the recursion is gonna work. So pass same error down. Schema AST, yeah. TMST source T and T name. This should be decal name. T decal name F F name expression iterator. But the token is the next. I think we are kind of there almost. The problem is that we need child and it needs to be somewhere. So child child. Um child. So if we pass it as we pass it here, that is the type that we're gonna test against, which is correct. But that is not the full type of the field anymore. Will that fuck up anything? It shouldn't. It will only, at worst, it will make error messages weird. Yeah, this is weird. F-type. Oh, F-type doesn't even exist anymore. F-type is actually F now. But this is weird. We don't want this. We want type name of at field type. F name. That means that this F name needs to be comp time, unfortunately. Either that or we pass around for. That doesn't matter though. That should be fine. F name. Field name. We have the info. Field info. Yeah, and we pass this, which we don't use F because it might be a um, subtype of the original field type. Hopefully this makes sense. Okay, we have some stuff to fix still, but so these error message should be happy. These guys below here should be happy. Dict sigil should be happy. Optional dict sigil should kind of be the same, except we do it on the optional child. So I guess we can copy paste. It's annoying because you kind of wish you could reuse the logic, but there's not a lot of logic, so this is fine. So this means if field info is not optional, optional is sigil. If field info is optional, and then we do Ziggy get option on field info dot child. Yes, so this all works. The only problem is that none of these can be pointers at the moment. By the way, we have another thing where somebody could put a pointer to something, and right now we're not really dealing with that correctly. Hmm. I also wonder. I hope that I'm not writing this the wrong way. Do I need to write also this with type first in mind? I might need to write this the other way around. Holy shit. Type inside might be a problem. Well, you know what? If it is a problem, we'll see in a moment. Um, or we can do it right away. Just comment this stuff out. Actually, this guy should go, but comment these two out and let's see how far we got. Oh shit. Which is incompatible with. Oh shit. Yeah, we would like to show this. Maybe expert source is something that we want to show. This guy is so naive. Also, we are really not guaranteed that there is a child. I'm also weirded out a little bit that this was working like this. I feel like there is something sus going on around here. But for expert source, yeah, let's just do no dot lock the slice. That's fine. Okay, let's see how we're doing in terms of ability to compile. Although I think I know for a fact that something. So this is fine. Okay, let's see. Let's see how we're doing. Exit not seen. See build. Build 494. Expected 7 arguments. Found 6. Yes, our own tests use the add. Use this thing. What? Found one reference? You're lying. Oh no, you're right. It's because we're using the internal one internally. Okay, so we're missing the schema path in here. What is the schema path? God damn it. Uh, and we can do this. I think this is fine. Okay, let's see how this goes. No. I do not believe for a fucking moment that everything worked first try this way. No, no fucking chance. No, 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 no. No, 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 no. No, 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 no. I so do not believe you. What the fuck? I so do not believe you. That is impossible. Yeah, that's what I thought. All right. It's because we're not doing Zig build test. We should be doing Zig build test to run tests. Okay. No field of main function name skipped in error. Oh. Okay. So now we get to fixing stuff for real. So this is a try. Expected error union type found void. This does not error out anymore. Expected use size found pointer to U32. Excusez-moi. Oh, is it me? I'm using get pointer. 81. Unhandled enum case. Yeah, this is fine. Yeah, this thing isn't a moving enum. This should not be like this, but whatever. Okay, is that the one that was missing? Expected structure union, blah blah blah. Found U64. Where? Oh, I think this is interesting. Field names. Yeah. Validate Z container. So I think that I cannot make get options work that way. That is interesting. So the problem is that get options, as it is implemented right now, will attempt to create an options T even when the T is not the right kind. Oh man, that is cursed. We need to prevent it from creating a options T return type when it's not those cases. So we need to do something like this. Okay, let's see how we do with this return type. Type void does not support field access. 184. Would inlining solve that problem? It fucking does. Okay, it does. That is delightful. It does. Okay, so we have solved all the metaprogramming stuff, it seems. The problem is, well, kind of, we're not exercising really the code below because we don't find matches. Unfortunately. So we need to change our test code a little bit. Also, let's see this. So this went from this to this, which I think it's fine. Oh no, this is fine, but also not fine because we need to make this resilient to we need to make this resilient. I think this needs to be just the final name or something. Or at the very least, we should resolve this to the root, to the project root. Can we resolve this stuff to the project root? Essentially, I would like to take this. Maybe that can be passed as an extra argument. Actually, it doesn't even need to be an extra argument because we can add a second file argument. Actually, add arg. And that's going to be root. What's subpath? No. Root dir.path. Path. Okay, we had a second argument, which is the root path that might or might not be there. So in type checker, we do the schema stuff, and then we do this. If maybe make this var, or no, we're gonna make display path. Display schema path is gonna be args it.next else schema path. Okay, what do we do in here with the root path? Relative resolve. Is it relative? CWD root path. Environment map. From 2. I'm not sure if relative is what I want. Returns the non-absolute path from to. Yes, that's what I want. Other than memory allocation, this is a pure function. The result solely depends on the input parameters. From and to each resolve the same path after calling resolve on each. A zero length string is returned. I just don't know what the CWD is. Actually, is the CWD a path as well? Yes. How do I know the CWD path? I have no fucking clue. Do you know your CWD path? It's not in init. I'm just gonna say root path. I don't know. Once again, the real path call. Okay. Oh look, we can even just compute this if there are errors because we're gonna use it here only. Okay, let's see how this looks like. Yes, that looks much better. Okay. So this test is fine. And this test needs to be adapted. So how do we do this? What we could do as an alternative is add another flag, another option to the type checker executable, where we say that when it comes to container decals, they all match the same name, even though they have different names. It's like a different mode of operation. We could do that. The problem is that that would cannot be actually cannot be a CLI argument, because that would have to be a com time argument. That would have to be a com time argument. Yeah. So here we would have also mode. We'll have mode, and then we would have to say here not the definition, not the container type, validate the container. But we lie about the decal name. We lie about the decal name, and we give as the decal name the first entry in the global scope. Okay. Okay, let's see how this goes. And now we need to add that module, that import. So Come on, doesn't B dot doesn't work? Oh, I don't have it. Project dot. Okay. Oh, this might need to be an if statement instead of a switch. Args contents, counter types, generated file, step add option path. Type, bool, name, testing mode, value. Oops, like this. Let's call it test mode. Maybe we can call it test mode and then enabled. Yeah, I like this. Okay. I'm renaming things a little bit. Test mode enabled, and then this becomes test mode. Then we go into our thing here. And then this becomes an if. Okay. All right. We need to update the call to this function. No. Yes. And we need to update also the one up top with false. Unable to resolve comp time value, right? Comp time. I don't think this needs to be comp time value. I don't think this needs to be comp time, does it? I don't think it does. I marked it as comp time, but I don't think it needs to be. We never use it. The decal name we never use for anything comp time, really. Field name maybe, yes, but decal name, no. Process terminated with signal abort. How? Assertion failure. Yes, I knew that the function was sus. Okay, this function is sus, and now I need to fix it. This is going surprisingly well. Uh, if we hit this is something we're hitting at runtime. It means that we built the executable correctly. That is blowing my mind. It means that we were able to weave all the logic correctly, even with comp time stuff. So let's fix this. Okay, so type expr. Also, I think it needs to be renamed. Let's call it field type expr. And so what we expect that you give me is a start field or a union field. That's fine. Or we can shorten this to says that it's called on a struct slash union field. Okay. So we don't do this because we need to do the +1. And it needs to return an optional. Hey Neuroside, is your flow working okay for you now? It is, yes. So far, I had no issues with it. By the way, I wanted to mention something to you. I was testing some stuff. I was testing issues with the Ziggy LSP the other day, and I realized that one issue that I was having was that I was requesting full document syncs, but I was receiving partial sync. But I was receiving partial syncs regardless. But apparently, I think Flow is not the only one that does this. I think Helix is also doing this now. I might be wrong, but in any case, that is not a problem per se because, at least for me, anymore because I added the missing code to accept also partial updates. But here's what I noticed in the meantime that I think you should be able to double check easily. I think that when a language server crashes, Flow is not reopening the documents that were open before the crash. Or at least I was experiencing crashes, which then would cause the server to restart. I would type something, and then the server now would crash with the error that it was given a partial update for a document that doesn't exist. I think. I wouldn't look into this too deeply. I would just double check if by any chance this might be a combination of things that you forgot to add to the language server handling. If that is not the case, then it is possible that I misunderstood what I was seeing in the error logs. So what are we doing here? Actually, we can even do this. because handling is different in these two cases. Oh shit. Also, field type expert. God fucking damn it. This requires also the node list. Okay, this cannot be implemented like this. Oh man. Yeah, this whole thing is a little bit wonky. Okay, I'll fix it in a second. There was a restart timing issue that I fixed 2 days ago, maybe update. I think I saw something about it, but if you think that there might have been some kind of race condition between requests and the process of the server restarting, I don't know, maybe. But it was more like the server crashed, got restarted, but then it did not immediately see a document open. It would see an edit to the document first. And I assumed that that was not a timing condition, but more like because, I wasn't like instantly typing in a way that I could cause a genuine race condition. I was just tabbing out, waiting, human time and then typing. So my impression was that the server just straight up had never received the document did open notification after the restart. So in any case, sure, I'll update. I think I have updated after that already, but and I don't see this anymore because I fixed the language server. But in any case, yeah. Okay, understood. Cool. Okay, so this function is S, man. So the reason why this function is S is because it takes a full node, which it doesn't need. It oh man, this needs to be so. This either is something that you call on the right kind of node. Okay, this has to be something that you call on the right kind of node. Yes, because you need to fetch that node no matter what. So this is fine. But then we need assert. We need to assert. You know what? I think this whole function is just useless. I don't think there's a way of redeeming it. So let's go. Let's go type out manually. Uh, let's go type manually what we would have done. There's no way around it. So field index is not the node that we want. Do we care about this node other than in these three places? Yeah, we don't. So this is not the node that we want. We want to look at field index. Actually, no. Yeah, we really don't want this. And we actually wrote this code already, essentially, which is we have Z code already. It's down below, right? No. This. You do +1, and then you do these checks. This is essentially it. So payload index, well, field type index. Let's just call it field type, I guess. Okay, something along these lines. So field type index, if it's low, if it's in the array and we grab the node and it has the same, if it has a different parent, we kind of want to return essentially. So we can say we only do stuff if it has the same parent. Do we assert this? No, we cannot assert this because cannot do the assertion because it could be a union that doesn't have any payload. So, but we can put continue. No, but we this is a comp time continue. We cannot put a runtime continue in here. So we can say if it is equal, then we do this. And this is going to be field type. This is it. Let's see how we do. Holy shit. We definitely are doing. This is giving us now a different output. That sounds like a regression. Let's take a look. This one is okay. So this is the schema case that's different. So this is fine. What's happening here? This used to say error 1, schema field B, missing from struct definition, does not exist in schema, does not exist in schema, missing from struct definition. Field C missing from schema, error 2. So this is correct. This is the B oops stuff. Okay, here's what's missing. Right. We have only implemented looping over the type and checking if it's in the schema, but we have not implemented it's in the schema, but it's not in the type. Those are like I had it before, then I nuked it, and I have not restored it. I wish I did not nuke it because then I think that is code that I could have copy pasted. But well, such is life. So we need to re-implement that, and then we'll restore the missing error messages. Frankly, I like this style more. I think we should print it dot something instead of saying field something missing from schema. I like more this does not exist in schema. I like this style more. Let's replicate that. Yeah. Yeah, why am I doing this? Oh my god. Clearly you want to do this. Clearly you want to do this. Clearly. Like even my own API is designed to work like this. Does not exist in schema, missing from schema. Okay. Does it work with the at names properly too? I don't know. That would be maybe a nice follow-up thing. Okay, so let's add the other way. Okay, we need to add the other way around. Then maybe we should test some of this stuff here. I don't know. You know what? We're gonna we're gonna test this stuff all right. Once we upstream everything to Zine. Okay, so how do we do this? Here we're testing that all the schema field names exist in the thing. Let's test second that all the things exist in the field schema. How? So we should be able to do container info dot. We should be able to. We made, I think, a static. Did we not make a static string map? Yeah, we made a static string map from a field enum. What a cursed thing that we made, but it was working. Const. Type map. Well, let's call it field map. Okay, I'm having a brief moment of brain fart. Looping over our struct fields, we test them against the runtime information. Now the runtime information needs to be tested against this. So this needs to be a for typescope.fields.keys. Okay, what error were we making? Schema field missing from definition. Okay, now the diff is different. Now we are sharing these, but 2 and 3 have changed. and that is fine. I think they might have also changed the position, but I'm not sure. Okay, so with this, we have fixed it. Actually, if I were to change this message to does not exist in schema, I'm going to do that briefly. I think the diff would essentially completely disappear. The order has changed. Does that mean that we were doing this afterwards? Yeah. Now the diff is fully the same. But I like missing from schema more. Actually, maybe this does not exist in schema, and maybe this can be made missing from missing field this. Yeah, missing means should be there because the schema says that should be there. While, yeah, so, okay, this checker should assume that the schema is correct and the type is wrong when there's a mismatch. So if the type doesn't have a field that is in the schema, it's missing a field. If a file has an extra field, then we should say this is an extra field. Uh, like field not in schema. Missing field B, field not in schema, field not in schema, missing field B. Okay, that sounds about right to me. Yeah, this code needs more testing. I'm not so sure that it is correct. Um, you know what? I expected this to be an easier journey. It was actually longer to get here. Holy shit! It took me 3 hours uh, to get to this point, but I guess such is life. So I think that these guys might need a little bit more work. I think at this point it might be a good idea to just make a zine release and call it a day. I can work on this stuff later today on my own, I guess, and push it to the finish line. Yeah. Okay. This was nice. So far, so good. And I'm loving these updates. We should be able also to print the type of a missing field. Can we print the type of a missing field? So, if instead of has, we do get. No, field map is fine. It's this guy that needs to have also values. What's in a field? The location as well for the name. You know what? We loop on values. Oh, this is funny. This was even the schema field. I got it completely wrong. Oh my god. Of course, it's a schema field. Um, but this is not the name anymore. Now it's values. Dot slice. Okay, have we preserved the functionality? Is the lock what I think it should be? It is what I think it should be. So functionality has not been impacted. Perfect. Next, we now know the index. And we can do this. We can kinda do this. A simplified version of this, hopefully. So have the name. If it does not have a name, then we care about the type. We certainly do not do this. We do not do this either. But we need some kind of like else or early return. So it's more like if we get all the way in here, we say missing field. Okay, let's see what it has to say. Yeah, I like this. Me like it. Okay, what do we do next? I think this is it for this section. I really put in there everything that I needed to put, I think. Yeah, all that remains is this complicated stuff down here. Okay, I think we're good. I could even commit and push this, but I think I'm gonna wait until I've fixed this stuff a little bit. like tested it a little bit more. The part down here is fine. We tested it just now. That's okay. These guys, I really just have no clue. I guess I could test them. No, Zinap streaming. I think I'm gonna do it tomorrow. At this point, I mean, I was not sure that we would be able to get to the full Zin upstream. Actually, wait, it's not upstreaming, by the way. Zin is not the upstream. We are the upstream when it comes to Ziggy stuff. But no Zin upgrading, yes. I didn't. In any case, I did not expect to be able to really pull it off in this stream, because we're gonna be faced with the real world complexity of all the serialization that's going on in Zine. So it's actually not bad if tomorrow's stream starts from that, because it means that I will be able to tackle it seriously during the stream. As for Zine publishing, I think I feel like taking a break. So what I think I'll do is that I'll stop the stream here. I'll take a break. I'll do the Zine release on my own later tonight or tomorrow morning. In any case, later. And maybe I'll work on this stuff a little bit more. Yeah. And then we publish everything. I'm actually looking forward to finally be able to use this stuff with Zine. It almost felt like, for the longest time, it felt like it would take forever to get to this point, but it was actually not that bad. I kind of regret leaving Ziggy to fester for so long. On the other end, though, I remember when I was working on this, getting to a point where I was feeling a little bit overwhelmed with all the stuff. So taking a break from it was a good idea. Yeah, but in the end, it wasn't even all that hard. Like, I'm doing it now. I even had to relearn all the things that I forgot about how my system would work, and it wasn't even that terrible. It took me like a couple of days just to get used to it by osmosis. So, and this is turning out to be a pretty cool piece of software. Like this is very solid. This is going to be like genuinely useful for people. So that, I think, is it for me. Thank you, everybody. I hope you had a good time, and I will see you all next time. Let me see if there's anybody that I should raid. Any obvious raid? No, sorry, I'm lazy. Thank you all. I'll see you next time.